Hello everyone, how are you doing today? Non-fam, Abdullah, bonjour, comment ça va? Santiago, hello. It's so nice to see you guys again. I like to see always the same name because we are having such a long topics that is good that people come back so that I can continue all the different topics. And today I actually finally have some papers, a pen, so that I can take some notes, so that if you have question I can answer, then I can just take some notes. If you have some specific topic, instead of trying to answer everything, then maybe I can try to organize a little bit. Then I will just record all the different topics, and then maybe for some next streams as well. So for Josiah, I think the last stream, I remember you were not there. I think it was too early, I remember. So we are back on the same schedule every Thursday 8:30, and then once a month I will try to make a special stream for European people. Non-fam, bon matin, loyal mouse. Oh, thank you for joining. Thank you for joining. So today's topic, we have a couple of them. Let me read that. The first one will be about layer adhesion. So we are going to spend around 15 to 20 minutes around layer adhesion. The second one is one of my favorite topics, which is the truth about PLA. So that there's a lot of thinking about what is PLA, and then the biodegradability, compostability about PLA. So, and then since we released our Polyterra PLA, I think we kind of brought back that topic, and I would like to clarify a few points about PLA. I've seen on Twitter someone asking, what's my thinking around polycarbonate replacing ABS, which I think is an interesting question. I don't think there's a lot of things to say because it will just be my own judgment, but I can share what I think about this. Another topic that was raised on Twitter was talking about the VOCs and UFP. So in 3D printing, which I think is a very important topic. Unfortunately, I don't have a lot of knowledge about this. I mean, I have, Google knowledge, but not so much experience, like doing testing myself about VOCs. But we can have a few minutes on seeing like what we are all thinking about this. And then that's it, I think, for today. So today I'm a little bit tight on schedule, so I will have to stop exactly at 1 hour. And by the way, if I forget to watch the clock, please remind me. But at least this topic, I will try to go into it. And then if you have some question, you can just put it in the chat. I will try to answer it very quickly. And if you need more detail, I will also record it here, so that in the next stream I can go more into details. So, Zomboni Girl, hi everybody. Thank you for joining. Transform LLC, thank you. Oh, Alex. So, Alex here, if I remember well, is the person that contacted us and to talk a little bit more about PLA. I don't remember exactly what topic, but I think that goes into the topic that we are going to talk about today, which is PLA in general, what Polymaker is doing in that direction, and PLA on the market in general. And Alex, if there is any part of the topic that I missed, please put it in the chat, so that I will try to get into that as well. Eric Albert from Pennsylvania, welcome to the stream. Titan Revenge, hey, thank you for joining. The guy that always print the right model for the right material, if I remember well. Josiah is coming with questions already. How about Nylon 11? Yeah, like I said, I won't be able to answer all of them. I will just record them. Nylon 11, which I think is more popular on the SLS, almost none on the FDM, but I will try to look into that. Got home from school just in time. Yeah, thank you very much for joining right after school. I guess, do you consider the stream as a rest after school, or do you consider the stream as an extension of your learning today? Abdullah, can you please complete the jam-free technology we were discussing on the last stream? Yeah, that's true. I will try to do that as well. I think I can do that one pretty fast, the jam-free technology. I don't remember which part I didn't say on the last stream, but let's do that as well. How long does it take for your PLA formula to degrade? Yeah, good question. So this will be covered in the second topic, partnership and innovation. Thanks, Nicola. Partnership. Oh, yeah. Okay. I remember. And then any thought on making food grade filaments? Ooh, that's an interesting topic. I don't think I will talk about this one today, but food safety in 3D printing is a huge topic. Record that as well. And when will you have a recycling program? Okay, this will also go into the second topic. Okay, one more. It is a little bit of both. I'm relaxing, taking a break from the books, but since I'm a material science program, this ties into schools. Yeah, great. Any thought on getting into other things besides filaments? No, I think I already answered that in one of our last streams. So the short answer is our company tried to really focus on extrusion-based 3D printing material, and I think we still have a lot to do in that industry. So we will focus on that industry first, and then think about what we could do further. Already banking commission on Polymaker affiliates. Yeah. Congratulations! Thank you for joining the affiliate program again. What happened to natural polyimide copier? Yeah, so very quick answer. For polyimide copier, the problem with natural is we had difficulties to control the color consistency from one batch to the other batch. So we decided to discontinue the natural, because even though it's called natural, some people were buying this for like having like a kind of a creamy color, but the problem is the consistency between one batch to the other was not good enough. So it's very hard when you don't add any color master batch to control the actual color consistency, because that would be from the raw material. So that's the reason why we closed that. Okay, so no more. I think I caught up on everything. Again, ask your question. I will answer as quickly as I can, and then I will spend a little bit more time on today's topic. So the first topic is layer adhesion. That was for Santiago. So layer adhesion, let's try to answer the question, how to improve your layer adhesion. You know that in 3D printing, the fact that it's layer based, you have a lack of isotropic in terms of strength. So you will always have better strength on the, whether it's tensile strength, whether impact strength, any kind of strength, you will have better mechanical property on the XY axis than the Z axis. And the main reason is because on the Z axis, you have a lot of different interface between the filament. Actually, this is not a problem only in 3D printing. I mean, in 3D printing is a problem from layer to another layer, but injection molding has exactly the same problem. When you inject something into the mold, sometimes you will have different routes, and then the path that the plastic will take, and then when the plastic will meet, then this is the same problem. You have an interface between the two material, and then in that seam, this is where they will have the same problem as 3D printing. From one layer to another layer, you have this contact point, and then from one path in injection molding to another path where they meet, they also have this problem. You will see a seam, and they need to work on the setting of their injection molding machine in order to solve that seam problem. So, actually, it will be very similar how they solve this problem and how we are going to solve our layer problem. So for our layer problem, let's go to the root cause. So the problem is what? The problem is you are dealing with two set of material, like two volume of material that go in contact with each other. So in order to increase the layer adhesion, you need to have something happening in the interface, right? So the difference when you have one block of material inside, how does it how does it stay a block, right? Because it's a lot of polymers. So you will have what we call entanglement between the different polymer. So that will maintain the structure of that block of material. So when you have two blocks of material that goes in contact with each other, what you want to do is to increase the entanglement between the polymer from that block and the polymer from that block. And so now the question is, so when I say block, let's take 2 layers, right? So how are you going to increase the entanglement between the polymers between these two? Well, the first one, in order for the polymer to go, and entanglement means, they go and hook each other. And in order to do that, well, first, you need the polymer to be able to move, right? If it doesn't move, then you won't be able to go and create all of these knots. So, for example, if I take 2 prints here, and then I put them together, right? Nothing happened. Why? Because they are what we call in a glassy state, which means the polymer is not moving. So I can put them like this, then they're not moving. So it will be very difficult for them to create entanglement and then to stick each other. So how do you allow the polymer to move? Well, you have to increase the temperature. Once you increase the temperature, you will make all the different polymers vibrate more and more and more, and then you will give them enough energy to just move around. And then how do you know where you arrive at the point where they move enough so that they can entangle with each other? Well, there is one temperature that we call glass transition temperature, which is at the point where it go from it will start to droop this way. So this above TG, if you have two material that are above TG, and then you put them together, then they will start to create entanglement between each other, and then they will start to stick to each other. So coming back to our layers, if you print a layer on top of the other one, the hotter you go, and the more entanglement you will create. So because you are going to give a lot of energy to the polymer, so they are going to move, and then they are going to create this entanglement. So if you are printing PLA, for example, let's say let's put the moisture issue aside, and then you just go up to let's say 260 degree, and then you print 260 degree on top of the other layers. So what's going to happen is the nozzle is going to heat up the material that you are extruding, and through the material that you are extruding, it will start to heat up the material, the layer you are printing on, and actually it will heat up all the layers below it. And then this will allow the polymer to stick to each other. So that's the first one. Let me erase that topic. The first one is temperature. The higher the temperature, and the more you will create entanglement, the higher the layer adhesion. But please make sure to understand that there is other limits. For example, for polysmooth, for example, PVB base or PVA, the higher the temperature, and the more you're likely to have some bubbling issue because of moisture. Actually, moisture is another topic we need to talk about, because you can have a material with high moisture content doesn't do bubble, and you can have a material with low moisture content and have bubble, because it has to do with the viscosity of the material as well. So maybe that's a topic we can talk about next time. So coming back to the layer adhesion, there's another limitation for temperature, by the way, which is your surface quality. The higher the temperature, the longer it will take to cool down, the longer it will take to freeze in place, and the more it will be out of shape. So the less, the worse the surface quality will be. But that's another topic, like how to have a perfect surface quality. So coming back to layer adhesion, temperature, the higher the better. The second one is the pressure. So let's say I have these two models. So if I put some pressure, the pressure, pressure creates stress, create temperature. It will also raise the temperature if I put some pressure to each other to a certain extent. So even if I'm not, this is theoretical, right? But even if I'm not above TG, if I press these two together for long enough, let's say 1 year or something like this, then you will actually start to create small entanglement between each other. So if pressure is a factor, then when you're printing your model, the nozzle will actually compress that the layer you are printing on top of the second layer, and this compression will also accelerate the behavior of creating entanglement. So now the question is, how can you increase this compression? one way is to slightly increase your extrusion multiplier or flow or whatever slicer you're using. But basically, the idea of extruding a tiny bit more than you actually need. And in order to not have your model look over extruded, you can compensate that with the extrusion width. So the extrusion width, you can, I give you a tip. If you increase extra 0.1 nozzle, will make the path calculation of your slicer slightly wider. So the excess will go on the side. So I've tried it, not a lot of time, but I've tried it like maybe 3 or 4 times. And that's how I try to experiment how to increase my my layer addition. So that's one tip for you on how to increase the pressure. You just extrude more, and then you try to compensate on the the line width that the slicer is going to think you are going to print. Actually, you're not going to print here, but it's just to compensate the fact that you have increased your extrusion multiplier. So the first one was temperature. The second one was pressure. Now the third one is time. So you need the longer, we talked about the amount of time that it would take for these to stick to each other, even if it's not above TG. And the longer, the better. So for your print, it's the same. If your two layers can stay in contact with each other at a high enough temperature above TG for as long as you can, then you will have a much higher layer adhesion. So you can do that exactly the same way you solve warping. Do you remember the last stream or 2 streams ago? We talked a lot about how to reduce the internal stress in your part. All of the solution you have found for this will work to increase the layer adhesion. Is exactly the same. Except the nozzle, except all the solution that is regarding the nozzle hardware. So, for example, higher extrusion temperature, higher chamber temperature, lower cooling fan. All of this will help to increase the layer adhesion. We always talk about I have delamination, etc., and then you will have someone tell you, oh, you have to remove the cooling fan or lower the cooling fan. Why they say that is because they want to make sure you increase the time the 2 layers will be in contact with each other at a high enough temperature. That's the reason why they tell you that. So that's for time. And the last one is the surface contact. So obviously, if you have more surface contact between one layer to the other layer, then you have more chance, a higher probability to create entanglement between the 2 layers. So what you can do is you can just increase the extrusion width of your outer shell, or maybe or the whole print if you want. But if you have 0.4 nozzle, just force, depending on the hardware you have, but just force your printer to extrude at a 0.5 millimeter width, and then you will start to have a much stronger layer adhesion as well. So all of these, temperature, time, pressure, surface contact, are all the factors that will make your layer adhesion greater. And now that you understand this, then you can see the whole bunch of solutions that are open to you to improve that layer adhesion. Okay, so that's what I wanted to say from layer adhesion. Let me see if there is any question I can answer quickly. So my copier is brownish clear. Yeah, like I say, for a natural copier, there is a slight difference from a batch to batch. That's why we discontinued that product 1 year or 2 years ago, I think. Santiago, on layer adhesion, what materials stick to each other? On layer adhesion, what materials stick to each other? Sorry, I'm not sure I understand the question. What theoretically any material bringing to a certain temperature will just stick to each other, or yeah, sorry, can you rephrase that question? Josiah, oh yeah, I have this recycled hips that has no layer adhesion, even with no fan, and every temperature between 245 and 280 EV draft shield. Okay, so that has no, and how about the XY brittleness? If on the XY it's very brittle, then it means the recycle, because recycling will lower the molecular weight of the material. You know, molecular weight means how long the chain is. Very simple definition. And the more you recycle polymer, and the more you are going to break down that chain, and then you will end up with a very low molecular weight. And what happened with low molecular weight is that, you know, there is less opportunity to have a lot of entanglement with each other. So it's very easy to just break it. I think low weight may, in some cases, means lower mechanical property, maybe because of the fact that the polymer are not long enough to form all of this knot. So if you keep recycling one material, then it will become very, very brittle. So if that's the case, then even if you try to force these layers together with all the factors that we talked about, then it's still not enough, because by definition, even on the XY, it was very brittle. But if you go to the extreme, you print very, very slowly so that you have the time, the highest amount of time, and then you print at very high temperature. But be careful with the moisture, because moisture will really affect the layer adhesion if you go on a higher temperature. That's the limit. And then you have a very big extrusion width and then a high extrusion multiplier. Then you must have a good layer adhesion, or there is some other factors that are affecting the print. Collie Logan, woodworking also has a problem with directional strength. Yeah, definitely. And that's exactly for the same reason. When the polymer is aligned, when you have alignment with the polymer, then you have the same problem. If you have strengths that are perpendicular to the alignment, then it will be very weak. But if you have strength parallel to the alignment, then it will be very strong. And for wood is the same. Why? Because wood is also a polymer, right? It's cellulose, and this cellulose is aligned. You know, it's all of these cells that are like this. So if you are basically hammering a nail through the wood, then most likely you will start to see delamination following this fiber in exactly the same way how if you put a nail through that print, then you will have delamination along the layers. So a very good analogy about the wood. Stephen Paul. Hello everyone. Thank you for joining the stream, Stephen. Could there be, Josiah, could there be a Polylight PTG Pro? Let me think. Yeah, there could be, but the Polymax PTG is already quite a good one, because the Polymax PLA is a very ductile material, which doesn't feature the same rigidity as Polylight PLA. That's why we released Polylight PLA Pro, to have something in between. Polylight PLA, very high rigidity, Polymax PLA, high tensile toughness, and in the middle, a little bit higher actually, you have Polylight PLA Pro that have almost the best of both worlds. Polymax PTG, on the other case, is not only very ductile, but it also have some rigidity. We could do even higher, but yeah, that's the reason why currently we haven't released that PTG Pro. And by the way, what do you guys think about PTG? Last year it was the big thing. Why? Because we had a shortage of PLA, so PTG just went like crazy. But now, if you look the trend, then it's going down. So I don't know if people are giving up of PTG or it was just a trend of the last 5 years. But PTG was like the material that the new one, easy to print, better mechanical property, better temperature, heat resistance than PLA, but still I see the PTG going down. So I'm really wondering, from your perspective, what do you think about PTG compared to other materials that are available nowadays? Asian Duke Box of Awesome. Will you have any more CF industrial filament like PLA CF, PTG CF? We do have. We have PA12 CF, PS6 CF, we have the glass fiber version of PS6 as well, and we have PLA CF already. We don't have PTG CF now, but we have a product that will be released in Q2 this year that are along this line. But PLA CF, yeah, we have it already. Loyal Moss, fantastic answer. Yeah, thank you. I hope all of this is useful for you guys. Josiah, what about PPCF with warp-free technology? I think we talked about this already, Josiah. The PP is a semi-crystalline, so it can use the warp-free technology that we are using, and the CF usually will already. And we have one material that is coming that is along this line. I will miss natural PLA. Yeah, sorry, but once we solve that consistency problem, then we will release it again. I love the color. Santiago, yes, for example, PP doesn't stick to anything but itself. Nylon, similar story. PLA with PTG to an extent. ABS and ASA very well. I'm guesstimating. Oh, okay. So what you're saying is when you print with multi-material, which one will print together, like will stick together when you print on top of each other? Okay, I understand. That's a good question. I have experience with PLA TPU. Well, the first answer is no. In my experience, there is no combination of two different material that will be as strong as the combination of two same material. So just to get this out of the way, because when I will say a combination is strong, it's not as strong as if you would have two same material, right? Even two different color would not be as strong as the same color. But I had good luck with PLA TPU, but it also depends which one you print on top of which one. I had good luck of printing TPU on top of PLA. I had good luck with TPU and nylon, if I remember well, copier. I had good luck with PLA and PTG, PTG on top of PLA, and then what else? Well, I didn't do a lot of multi-material, but and from a science perspective, how to know whether two material will stick to each other, I don't know. I don't know how. I guess it's like some kind of compatibility between the two molecules, like how each molecule would have a. Yeah, maybe not. I don't know. Let me record that. Let me brainstorm around how to know whether two materials would stick to each other. Well, the best way, you just try. That's the best way. But we can try to find some kind of logic, like some scientific logic behind, to see how we can predict. Okay. The next one is Josiah, 1.2 millimeter extrusion width for the hips, completely dry, 2-layer strength isn't maybe. Yeah, I'm not too sure. I'm not too sure what's going on with this hips material. If copier doesn't work without adhesive, might be the same for a PPCF. If copier doesn't work without adhesive, might be the same for PPCF. Yeah, I mean PP will come with the warp free, so I don't sure I understand, but they will have similar behavior on the printing bed. PCTG is better. PCTG. Okay, let's talk a little bit about this. I'm not sure if you went on the website, but I wrote something in our Polymax PTG, because a lot of people are talking about PCTG. So I was wondering. First, I mean, I encountered this material, I think 4 years ago or something like this, where when Essentium released PCTG, and then a lot of people are asking about PCTG. So let's take 3 minutes on that topic. If you go on the website, which I am now, and you go on us.polymaker.com. And then you go on Polymax PTG. You just go in the search bar, Polymax PTG, and then you just click Polymax PTG. And then in the description, there is the first question I wrote is, what is the difference between Polymax PTG and PCTG? And here you will have something I wrote, and then you will have an understanding of what's actually the difference between both, why people like PTG, why people like PCTG. And I think once once you read that, if you have some other question related to PCTG, then you can let me know. But I talked about how do you compound these two, like how do you create PCTG and PTG, and I talked about depending on what diol you're using during the polymerization, what kind of property you have on the end material. And then I talked about the why Polymax PTG for me is better. And I'm not even talking about the cost, right? Because PCTG is much more expensive than PTG or PTG with our nano reinforcement technology. So please have a look at this for the people that are interested in that difference. And then if you have some other question, just let me know in the chat. Some people just buy what's cheapest. Yeah. So PTG will be cheaper. I really don't like PTG. It's very mechanically unpredictable, even from the same spool and setting. Yeah, I think I felt that, Santiago. I think a couple of times you mentioned that. So I have to say I don't have a very similar experience. I don't know if you are using our PTG and if our PTG from one spool to another is different. If yes, then I will have to look into that. We try to have a certain quality standard on the property of each material. So if they are different, it means that somehow if they behave differently and you feel that they behave differently for exactly the same G code, then most likely there is a property change from one spool to another spool, and I will have to pinpoint that because we do want to have a certain consistency, a great consistency from a spool to another one. Comic Edge Clothing, hi. Well, thank you for joining the stream again. I think I've seen your name before. Abdullah recently had a part printed in Copier that warped a bit during annealing, even though it was a slow heat ramp. Part was also fairly small and thin. Oh yeah, that's a very good point. Actually, for very thin walls, Copier and actually I think most of the nylon will have a certain warping behavior. Mainly, actually, you also have the same problem with moisture. When you have a moisture saturation, if it's a very thin one, then it will warp a little bit, and the crystallization will also do that. The main reason, I believe, is because of the fact that it's small. I think it doesn't have how do you call that, structural integrity, or like it cannot hold itself. It is too asymmetric, and that's why it will have this warping effect. I actually can draw a graph for you that explain this properly, but let me write this. I will try to draw something, and then I will post it. But I think because we had this issue a lot, especially when we were dissolving PVA, so our polydissolve S2, and then we had this very thin part of Copier that were warping. So yeah, so the answer is yes. I mean, it's not normal because we should have been able to solve that problem, but we know that problem, and I think we know where it comes from. So yeah, so for thin layers, indeed, we have we had the same experience. Coley Logan, I've had a lot of good luck with PTG, though it always seems like to have better adhesion issue when I switch back to PLA. Also, you mean you print a lot of PTG and then you switch back to PLA, and then the PLA had issues sticking with the plate, if I understand well. Yeah, could be depending on the bed you are using. Maybe PTG stick very well to a certain component of the bed, and then as you print, you will remove that component of the bed, and then you print PLA, and PLA use that component to stick, and PTG just used all of it. So could be that. TPU-CF. Yeah, TPU-CF is a good idea. We have another one that is coming I don't know what exactly application you have in mind for TPU CF, Josiah, but we have another TPU that will be launched in Q2 that should be, depending on the application, but I think should fill that gap. PC ASA filament, never thought of this. I'm not sure if the ASA, the weather resistant, because there's a lot of PC ABS, going from PC ABS to PC ASA would mean that we somehow want to add that weather resistance, but I'm not sure the weather resistant from ASA would still be useful when mixed with a PC that have special properties when it comes to weather resistance. So I'm not sure about that one. Tech Generate, I like both PLA and PTG, right? I have a sudden urge to buy more filament. I love filament. Yeah. You know, the last stream we had together, Loyal, when I saw the amount of spools you have, it's like, I think you have more than we have here in the office. That's just crazy. I mean, I'm not even joking. I think you have more than what we have in the office. And I have to say we have a lot. What about high temperature PTG? High temperature PTG. Then that would be a PET, right? High temperature, yeah, a PET that you yeah, because the glycol, the modification you do with the second diol will lower that TG, right? And so if you don't want to lower it, then you just go back to a PET, right? Something like this, I guess. Good. Just fits a new log. Oh, that's the discussion. How would you stop a print warping, pulling away from the build plate? Warping is a big topic. I think I spent a lot of time in 2 streams ago. I think if someone would be nice enough to share the link for Comic Edge clothing, we spend a lot of time talking about warping. So maybe my suggestion is to go back to the other stream, and I think we really go into detail. Or you can have this book. I wrote a chapter on this book, and there is a whole part that talks about warping in detail. I mean, after you have this knowledge, I do think that warping will be no secret for you. You will be able to solve warping very easily. So that's my recommendation. Unfortunately, I still have a couple of topics, so I would just redirect you to the other stream. Higher bed temperature, yeah, that's one of the solutions. Again, I don't like giving solution. I prefer explaining what is happening. After you know what is happening, then solution will come to you very, very easily. Santiago, nano reinforcement fillers increase impact strength but decrease modulus and tensor strength. Yet Polymax PTG is even stiffer than Polylite PTG. How does that work? Polymer chain branching. Not really. It's I will have to go to the other topic, but very quickly, it's about how you process the material, how you extrude the material, like the whole process, because we have a compounding step and then we have the extrusion step. So depending on how you do this step, you can regulate the modulus of the material on keeping the quality of the raw materials. Let me record that. That's a good question. Nano reinforcement PTG stiffer. Okay, let me try to go very, very, very quick. Maybe it works similar to Polylite PLA Pro. Yeah, PTG PLA Pro, if we release, will be similar. TPU has such good layer adhesion, and CF make it rigid like PLA. Yes, TPU has one of the best layer adhesion. Mainly, we talked about TG. TPU is always above TG, right? I mean, kind of, because TG means on the rubbery state. So maybe that's the reason why it has such a good layer adhesion. But CF will really affect that. So I don't think TPU CF would be as good as we could think. I'm using G10. Maybe I will try giving it a sending with blah, blah, blah. Speaking of PET, what about CF PET? Yeah, that's a good idea. I think there's already CF PET on the market. I think, what's the name already? A Spanish company that do the dual extrusion, the IDEX dual extrusion, the Sigma printer, BCN. I think BCN just released the PET CF. I would have to look at their properties to see how is it working. Is it a good material? Is not? You are wealth of knowledge. I'm just sharing. I mean, all the knowledge I have, I don't have any 3D printing background. It's all the knowledge that the community has gave to me. and now I'm giving back. I'm processing with a certain science logic. I like science, and then I'm just giving back. I have about 2,000 spools. Oh my God, 2,000 spools. That's just crazy. What got you into the business filament? I can talk a little bit more about myself, maybe in a different stream. I will go back. Missed that episode. Yeah. Sorry for not talking about that warping, but I'm sure you will find good knowledge in that other stream. Him into the business. Polymax PC is indeed my favorite filament. Loyal, blah blah blah. I also okay. He's printing a clone, blah blah blah. Any interest in PHA? Not at the moment. Not at the moment. But okay, let's go into so Alec Brewer. Thank you. So I think I caught up on all the chat. So let's talk about PLA now. The truth behind PLA, and maybe at the same time, Alec, if you would be willing to write a little bit about PHA, like what's your understanding and why you think PHA would benefit the 3D printing industry, and then at the same time, I'm going to talk a little bit about our Polymaker and what improvement we did with our PLA. So the truth about PLA, what you know, when we released the first material in 3D printing was ABS. Why? The main reason it was ABS because it came from the injection molding industry, or at least that's what I think. That was the cheapest material. That was the material that you can remold. You can just heat it up and then mold it in different shape. So we just use it for that new technology that we're able to process thermoplastic, which was 3D printing. And then we noticed that actually when it comes to 3D printing, ABS may have a lot of limitation, whether it's the warping issue or whether it's the smell when you're printing. And then came PLA. We realized, oh, PLA seems to be a great material. It prints very well and it's biodegradable. Okay, biodegradable. That was kind of the word, the green word during the beginning of PLA. For me, I do think bioplastic is a great thing. So why bioplastic is not a solution yet? I think bioplastic solves one problem. It solves the sustainability of producing plastic. So you can produce plastic in a very sustainable way, in a way that, for example, PLA, you don't need to use any fossil energy to produce PLA. So for me, that's the big advantage of bioplastic over petrochemical and plastic based on oil. But one thing that bioplastic is far from having solved is the other side of the spectrum, which is the end of life. Even though we are producing from a more sustainable way, at the end of the day, all the plastic, they go exactly in the same way. They have the same end of life. So that's the part that we are really trying to find solution. And actually, by the way, if you are interested in this, I highly recommend to go on NatureWorks website or to follow some NatureWorks webinar. Their knowledge on that topic is very, very, very high. And I mean, that's the dream of their company. So I highly recommend to follow them. But coming back to this, so what are the end of life of PLA? First one is mechanical recycling. I'm saying the possible one, not the one we are doing now, because we are definitely not doing that first one. But you can mechanically recycle. You just get a bunch of PLA together, and then you just chop them, and then you just remold them into something else. So I guess that's what we call mechanical recycling. A second one is chemical recycling. You just take all the PLA, you use some kind of chemical reaction in order to break them down into lactic acid again, and then you use that lactic acid to make some more PLA or for something else. So that's chemical recycling. Another one is landfill, which is currently the one that is the most used. You just gather the PLA and then you just bury it somewhere. So that's another another end of life. Another one is burning. You can just burn the PLA away, and then don't talk about it anymore. So currently, if I remember well, most of, I don't know the number, but let's say maybe 90-95%, that would be my feeling, end up in the landfill. Oh, I forgot the most important one, the composting. Another one is biodegradation. You just send it to a industrial composter, and then it will just biodegrade in the compost. So that's kind of the five that I have knowledge of. And right now we are mainly using the landfill. So we are just burying away the PLA and hope that nobody sees something like this. But obviously that's not the best, right? Because if you keep producing plastic and you don't know what to do with the plastic, then every day there is tons of plastic that is producing, a very few that are that has a decent end of life. So the amount of plastic in the world is just it's just growing like crazy, and then end up in the ocean. So what we try to do is with Polymaker PLA is this. Although the regular PLA is already compostable, what's the issue with compostability? The issue is that the composting facility, they don't want to take PLA because it doesn't add anything to their business. First, it's harder to compost than just food waste, and second, so first it's hard, and second, it doesn't add anything to. So if they could avoid taking, then they would gladly do it. The only way they could, another reason is that it takes much longer to compose than their regular food waste. So the only way right now they take PLA is if it would bring more food waste. So I remember a story from NatureWorks that were doing the coffee cup, the coffee, how do you call that, a capsule that was made of PLA. And the fact that if the composting facility take this PLA, then they would have all the coffee waste with it. So one way is that the fact that they take PLA bring them more food waste, and that's good for their business. So that's one way they would take PLA if it's mixed with food waste. But our PLA print is definitely not mixed with food waste. So what we try to do is to develop a PLA that use less PLA. So what we are trying to do is to use less bioplastic and more natural occurring elements. So some stuff that you find around, like minerals. Minerals, we are trying to use a specific formula that has much less bioplastic. Actually, I forgot to check with R&D how much I can say about the formula. So I think there is some percentage that I can share, but I will double check and then come back to you. But there is a large amount of PLA or bioplastic that we are saving out of this. So you end up with 1 kg of filament that works exactly the same as your regular PLA, with a nice matte finish, very good printability, very good price, and a certain percentage less of bioplastic. And if you multiply that percentage to the tons of Polymaker PLA that are used, then we saved a huge amount of plastic. So that's one way Polymaker PLA really help. Why we are saying that this material is more sustainable than regular PLA. That's one of the reasons. The second reason is the fact that the new formula, the fact that there is less PLA, and the fact that we have formulated in a certain way, make the compostability faster than regular PLA. So, I mean, the obvious reason is you have less to degrade, because part of it is naturally occurring element. So it doesn't need to degrade. It's already in the final form, the natural form. and there is less PLA. So you only have a small portion that needs to degrade. So that's one of the obvious reasons why it degrades faster. So why this is not a final solution? Even this PLA, I believe composting facility would not take it. So we are not saying we solved the problem. Just throw away your polytera PLA in the food waste, and then it's done. It's a step forward. We are taking a step forward to help the industry finding a solution to the end of life of PLA. And on our side, if we can try, if the composting facility, the issue is that it's too hard to compost PLA and it takes too long, then our goal is to try to make a PLA that would be faster or easier to compost. So that's the step we are trying to do with polytera PLA. And the last thing is obviously all the thing that is around polytera PLA, the Carbospool, the papercraft sticker, everything coming from recycled cardboard. And we are really trying to make a difference with the tree planting. So, a lot of people are doubtful whether we are actually planting a tree or not, which I totally understand. And actually, there is someone from Instagram called Vlad, and his Instagram was, I don't remember the name of his Instagram. I need to check. But he actually called one tree planted, and then he asked, how much tree we actually planted, like, which is actually a donation, $1 one tree, a donation to one tree planted, and so he actually called the one tree planted, and then that's how he confirmed that we actually planted a tree. Actually, he confirmed that we planted 78,000 trees, but on our website is written 111,000 trees. So he said there is a difference, but he said we are still doing it. So the difference, which I wrote to him, the difference is because we are making the donation each quarter, and I still didn't process the Q4 quarter. That's why there is a difference, but it's processed now. So that's the reason. So that's with the amount of time I have, that's what I can say with polytera PLA. But I'm sure there's a lot of questions. So what I would like is you guys ask question about what you think about PLA, or what you thought was right about PLA, or what do you think PLA is the right way to go to make 3D printing a more sustainable industry? And at the same time, I will try to read what Alec has wrote about PHA, which is another interesting topic to talk about. So PHA, fully bio-based and biodegradable, has great barrier property and blends well with PLA. I spoke with another 3D printing company who is using it, who cited it has an excellent who cited it as an excellent addition. So this is the same. When we say is bio-based, okay, it solves part of the problem about the resources, and it's biodegradable. So biodegradable, I would have to investigate more how the PHA is biodegradable. If it can help the PLA by blending it with the PLA, if it can help composting faster, and if it can help us to get this PLA to composting facility, which is a huge challenge. I don't want to lie, it's a big challenge, but we have to start working now. If we want a sustainable future, we have to start working now. So on that topic, I don't have the answer now. I'm not a big expert in PHA, but I've seen PLA, PHA blend before, but I don't have any data. By the way, polytera PLA has all the compostability data, all the reports on our website. If you go on our website, you will be able to find a report. Like we are using a standard on how to compost the polytera PLA and compare to a regular PLA, etc. We want to be as transparent as possible when it comes to being sustainable and eco-friendly. We don't take eco-friendly as just we are eco-friendly, great, buy our materials. We want it to be real. We want us to say eco-friendly because something. If someone asks, why do you say your polymetallic PLA is eco-friendly? It doesn't even degrade or something like this. Then I want to have a strong and science-based answer. And I hope I provided most of the answer today. I'm also trying to find. Oh, sorry, skip. I'm also trying to find a PHA manufacturing company. So I'm a bit biased, but a huge advocate of it. Yeah, I mean, it's interesting. Maybe once I figure out how to bring someone on the stream, then we will have some guests. Then I would really like to invite you, Alec, to talk a little bit about PHA. I don't have much knowledge about it, but if he can help us into our mission of trying to drive the industry towards a more sustainable future, then I would really love to learn about it. Ingeo 3D, Josiah, yeah, that's a grade of NatureWorks. So yeah, by the way, the PLA, because even the PLA production has a lot of let's say questionable parts that NatureWorks ensure very well. A lot of people are saying, in order to produce PLA, we are using a lot of, how do you call that, feedstock, or a lot of corns that are supposed to be used to eat or something like this. But I think there is a lot of misconception. That's why I really invite you to read more on NatureWorks website. And again, for everything, it's very good to always criticize a little bit what is around. Like when we say polymetallic PLA, the product is more sustainable, more eco-friendly. I like to have people coming to us and asking why. Why do you say that? What's the proof? And I think that really helps science going forward. And even NatureWorks has a lot of information, but it doesn't hurt to go and cross this information with other sources. Even though I really trust NatureWorks information, I think they have a good way of getting the data, and I think they are very transparent. It's always good to cross information with other sources as well. And for PHA is the same. I have a lot of information about PHA that I read, but I would love to cross the information with you, Alec. To my understanding, ISOD is primarily used for impact testing of plastic, but from TDS, Polymaker use Sharpie. Are the results similar, comparable? Similar, yes. Comparable, no. You cannot compare results from Sharpie impact strengths to the ISOD impact strength in the same way you cannot compare a notch specimen to an unnotched specimen. But they will be similar. Usually, if you compare two materials for the same, if it had a higher ISOD impact strength than another one, then it will have a higher Sharpie impact strength than the other one, usually. By the way, if you don't know the difference, for the people that don't know, if I remember well, the ISOD will hold the part on both sides, if I remember well, and then the hammer will go in between. On the Sharpie, it will hold it on one side, and then it will just break like this, if I remember well. That's the main difference. And then notch or not notch is the notch will provide the beginning of the fracture point, and some of them doesn't have any notch. Is it ColorFab PLA PHA? Yeah, I do think ColorFab has a blend already. Maybe we can go and check this particular blend. What making the material more sustainable? By the way, I don't even know the PHA how it will improve the printability, like the surface quality, the mechanical property, the printability, the stress, all of this. So, Alec, if you have some information about that, maybe you can share some graph or some data. I think the community would love to learn more about PHA as an additive for PLA. Santiago, on Sharpie, the impact is right in the middle where the notch is on the ISOD, away from the notch and clamp, maybe moment. Okay. Yeah. So Santiago already explained. How does it affect the mechanical property? For PHA, Asian jukebox, awesome. Yeah, I think I have the same question. How PHA affect the printability, mechanical property, and thermal property of the material? Santiago, I think not. Josiah, will there ever be a filament dryer from Polymaker? Maybe. I don't know. Santiago, there is. It's not a dryer. It's a dry box. It doesn't dry the filament. It maintains the filament in a dry environment. That's the Polybox, which I don't have here. Polybox is desiccant base. I mean, a heated one. Yeah, correct, Josiah. I don't think Polymaker has an active dryer yet. We don't have at the moment, correct? What does Polyflex TPU95 clear look like? A clear TPU? I don't know how to say. I don't have a. It's just a TPU, but it's transparent. It's clear. Nothing very special. Well, except that is clear. Alec, it does. Microbes can eat it. It does. So you mean microbes can eat it? So you mean it's biodegradable? Is there any special condition in order to degrade PHA when it's mixed with PLA, or you can just throw it on the street and then it will degrade naturally? Linoleum filaments, antibacterial based stuff. Yeah, I think I've heard about this company as well. I'd love to join and would be happy to help. Yeah, definitely. I just need to figure out how to have, another, like a split screen with the guest and me on the side, and then we just talk to each other. Hey, chat, Schmid Tech, welcome to the stream. Unfortunately, we are reaching the end of the stream. I couldn't talk about the PEC and ABS, VOC, and all of this, but I recorded everything. Hopefully in the next one. Thank you so much for this. I've learned a lot. Looking forward to having you as a guest. Thank you, Loyal. Thank you very much for joining. And yeah, I'm really looking forward. For those that doesn't know, I will join a stream with Loyal, and we are going to do, I guess, similar to now. We are going to nerd around 3D printing. He has an awesome community, and he's really pushing 3D printing forward. So I'm really happy to be a guest on his stream and talk about 3D printing. Alec, gotta go. See you soon. Yeah, see you soon, Alec. Thank you for joining and sharing more about PHA. Question from Schmid Tech: will Polymaker be making any two-color quantum type PLA? Not at the moment. We like when we come up with with a great idea or maybe a different color. But right now, I think Matter Hacker, right? I think Matter Hacker has an awesome quantum PLA. We could make exactly the same, but we are trying to drive the industry forward. If the industry is already at a point where they have quantum PLA and it's working well, then maybe some other color we can release, or maybe we have another idea that are in the same branch. But at the moment, Matter Hacker are doing very well. I highly recommend that PLA as well. I think it's awesome to have that both-sided color. Loyal, he would be a great guest on the LM show. Thank you for supporting my try to get into the screen of Loyal Moss as a guest. Josiah, PLA PHA is tougher than normal PLA. Okay, so it acts a little bit as a toughened agent or something like this. Question B: will Polymaker be making any 4-color quantum type PLA in 2.85? I'm not sure. I don't think so. At least in the short term, I don't think we will have a 4-color quantum type PLA in 2.85. Do you have an Ultimaker or a Loosebot or a BCN? I think BCN is using 2.85 as well. Yeah, I added on the website a warning because a lot of people buy 2.85 and finally they realize the printer only takes 1.75. But I'm wondering how many of you still use 2.85 millimeter filament, and do you think there is an advantage of using 2.85 over 1.75 printers? I mean, except the printer itself, right? Loosebot and Ultimaker are very high quality printers, so most likely the printer itself will already be better than some other more average desktop printer. But just the filament itself, do you see any difference when it comes to 1.25, 2.25, which I have a lot to say about it as well. What's the difference between both? Why do we have two types of filament on the market? We can talk about that topic in some other stream. I think there is something on the work is for biocolor in the work. For biocolor, we do have, we are trying to develop some specific things that are a little bit different from the quantum PLA, but yeah, along the same line. Actually, you can see somewhere, somewhere in my background, there is a filament that you guys that we are talking about now. Somewhere in my background, you can try to find it. It's like a small sneak peek for a future filament that we are going to release. Loyal, we have to pick up a date. Yeah, definitely. Santiago, thank you, Nicola. Thank you. Okay, thank you, Santiago, for joining every week. I would buy a Polymaker dryer. Dry box works great. Yeah, well, every time, Brian, as soon as we have an active drying, I will definitely let you guys know. Linear neon filament was a joke. Linear is a floor material. Actually, there is, if you look at, I think the name of the company is a company that do fishing from fishing net, like a fishing net in the ocean to PET filament, and their name is, well, apparently not this one, but you can check. Most likely very similar to this one. That's why I say I heard this company. You can check transforming ocean waste to PET filament. Thank you, Bitsy Kodiko, for joining. Christopher Fraser, thank you also for joining. Maziri, already 1 hour. Oh, that's true. Thank you very much. So I will have to close this. I think I have a few more chat. Is race 3D filament the same as Polymaker filament? I already answered that question in Loyal Moss stream. We are making great filaments. If you think race 3D is great filament, then I'm happy you compared the two. Christopher Fraser, 3-color quantum. Yeah, that's also a good idea. Although I don't know how it would look like on the print. Loosebud. Oh, you're using Loosebud. Great, very very good printer. Me 2.85 and in Canada. We do have actually almost all our filament come in 2.85, but doesn't have the same color range. Josiah, also, what about making a filament extruder? I think 3D Devo is already making this pretty well. We are more dealing with big machine, and they are trying to miniaturize the extrusion machine, which is a very big challenge, and they are doing this very well already. Coley Logan, what about dual material filament? Different from core to outer? Yes, that's also some of the project we are trying to develop. That's a good idea, like a softer core and then a harder shell to print well, but being flexible. You can have also maybe a layer of conductive filament and then stronger filament in the middle. Blah blah blah. There's a lot of opportunity once we can co-extrude filament. Christopher Fraser and Schmid, thank you for answering my question. You are very welcome. And I think that wrap up our stream. I think I caught up on all the different questions. I think I've been able to cover two of our topic, layer adhesion and the truth behind PLA. Thank you very much for all of you for joining our stream. We are live every Thursday from 8:30 to somewhere around 9:30, but usually it takes a little bit longer. So I hope to see you guys in the next stream, and please come with a lot of questions. I love questions, and that's the way we can understand more our industry. Thank you again for joining us this week.